Hi everyone, my name is Ihan, and we're gonna do the question 7 of homework 9. Let's begin. So a task to prove that a random telegraph signal is a SSS process. So actually here what we wish to show is that the problem of yt equals to yn and yt minus 1 equals to yn minus 1 and until to the yt1 equals to y1. This probability will equals to the probability of ytn plus the epsilon equals to the yn, and ytn minus 1 plus epsilon equals to yn minus 1 to the yt1 plus epsilon equals to y1. And this is for any n t1 to tn and epsilon as the definition of the SS process. And in this proof, we want to use an example to show the ideas of this proof. So we will set an example at the probability of ytn equals to 1 and the condition ytn minus 1 equals to 1 and to the yt1 equals to 1. And we know that SS process is actually we know that a random telegraph signal is a Markov process. So this conditional probability just equals the probability of ytn equals to 1 and the condition ytn minus 1 equals to 1 because it's only related to the ytn's 1. And this we can see this is a telegraph signal figure, and this conditional probability is actually equals to the probability of in tn minus 1 to the tn, and the number of nodes 0 is actually equals to even. And based on the calculation we do for the telegraph signal, we know that this probability actually equals to the minus lambda of tn minus 1 power of e times the cosine h lambda tn minus 1. There's hyperbolic function here. So we know that this probability of ytn minus ytn equals to 1, ytn minus 1 equals to 1 to the yt1 equals to 1. We use the chain rule of the conditional probability that this equals to the probability of ytn equals to 1 and the condition ytn minus 1 equals to 1 to 1t1 equals to 1 times the probability of ytn minus 1 equals to 1 and the condition ytn minus 2 equals to 1 to the yt1 equals to 1. And this times goes continuously and to the probability of yt2 equals to 1 and the condition yt1 equals to 1, and at last with time, so probability of yt1 equals to 1. And all of this is actually Markov process, so it equals to the probability of ytn equals to 1 and the condition ytn minus 1 equals to 1 times the probability of ytn minus 1 equals to 1 and the condition ytn minus 2 equals to 1. It goes iteratively to yt2 equals to 1 and the condition yt1 equals to 1 times the probability of yt1 equals to 1. And we will just substitute this into this, and we know this conditional probability is a function of tn minus 1, and we know this is a function of tn minus 1 and minus tn minus 2, and we know that because it's a random telegraph signal, we know that the probability of yt1 equals to 1 is actually equals to 1 over 2, 1/2. So we can substitute this into it, and we know this is and minus lambda of tn minus 1 power of e times the cosine h lambda tn minus 1, and each item goes the same, and the last will times 1/2. And then we know that the probability of ytn plus epsilon equals to 1 to the yt1 plus epsilon equals to 1. Actually, can still use this same equation, and it will equals to the minus lambda times Tn plus epsilon minus the Tn minus 1 plus epsilon power of e times cosine each lambda goes the same, and each term goes the same. And we know that we can cancel epsilon in each term, so it will still equals to this minus lambda times Tn minus Tn minus 1 power of e times cosine each lambda Tn minus Tn minus 1. So this will equal to this. So that's what we want to prove here, and so therefore we know that a random telegraph signal is a SSS process. The proof is done. So thank you.